In Vedic mathematics, what happens, apart from using the regular sutras, okay, and there is something called special cases, and these special cases are so unique. The moment you understand certain property, immediately I start getting the solution for that, immediately I start getting the answer for that, okay. But there also, remember, I use the steps, but I use it in mentally, okay. Now let me take one such special case, okay. Now please tell me what is the product of 3 into 9. Sure? 27? Any of you got 25.3 or something like this? No. So 3 into 9 is 27. Wonderful, wonderful. I write 27 here. Good. Now let me take another example, and you should tell very fast, okay. If you want to use your calculator, no problem, okay. Let me take 42 into 99. Tell fast. Oh, some of you did it fast, right? Did you use your calculator? Okay. Now let me take another small example. I feel to do Vedic mathematics, this board is very, very small, okay. I need a very big board for that matter, okay. Let me write a very small example because it's a very small board here. Shall I write it? Okay. I just write the numbers randomly, whatever it comes to my mind, okay. This is enough? Okay, I've taken a very small example, no? Did you understand why did I ask you to use calculator? This you cannot do using your calculators also, okay. It is beyond your calculator's number of digits. Now what I do is I multiply this with how do we do this? Is it difficult? No, certainly not. It is not difficult, but it takes more time, right? Because every time you start multiplying and adding it and everything, okay. And meanwhile we commit some mistakes also there, right? You have to agree with that. Now in Vedic mathematics, as I told you, there are several ways to do this, okay. Not one way, not one way. I can use different sutras for this and start using it. But this is another entirely different method where I observe certain property and then I start using it. And now and onwards, whenever we are using Vedic mathematics, let us understand why I am doing like that also, okay. That is what is mathematics. And normally I say, when you solve a problem very quickly, it will become a trick, okay. Of course, when I do this in a few seconds, it becomes trick. But the moment you understand the reason behind the trick, that becomes mathematics. Okay, we should know the reason also, that is very important. Now we will just do the trick, later we will analyze the reason. Now you see this, as I told you, I can do this in several methods, but now using it as a special case, 9 is a special case, okay, any number multiplied by 9 is a special case. Considering it as a special case, I can do this in few seconds. You want to know how to find the product maybe in maximum in 2 or 3 seconds? Yes, you would love to, correct? And I am sure that you will immediately go start sharing with others, right? That is the joy of mathematics. Now we will do this. See what I do, considering it as a special case, it's simple. If I have to multiply 3 and 9, okay, there are other methods, as I told you, we will learn when we learn the sutras. Now considering 9 as a special case, we will do it. What I do is, I just make 1 less in 3, and for this also I use a Vedic mathematics sutra. And how many sutras are there? Can you remember? Yes, very good. 16 sutras are there. After that I use one sutra, and as I promised you, these Vedic mathematics sutras are simple sentences, okay, easy to remember. One sutra says Eka Nyunena Purvena. Eka Nyunena Purvena. Eka means what? One. Nyuna means less. Purva is previous. That's all. The sutra says Eka Nyunena Purvena. That means one less than the previous number. Okay, that's what I do it now. See, now it is 3. I make 1 less than 3. What is 1 less than 3? 2. Correct? And this 2 I subtract from 9. 9 minus 2 is how much? 7. And that 7 I write it here. That's all. I got the answer. I didn't use the multiplication table at all. Right? See how simple. I just made 1 less in 3, that is 2. And this 2 I subtracted from 9. 9 minus 2 is 7. That's all. Easy. And the beauty of mathematics is, once if you understand certain property, then you can solve any example of that kind using the same property, same principles, same methods. Okay. Now that I got the answer for this, is it difficult to get the answer for this? No, not at all. It's a child's play. Now you see what I do. I just use the same sutra, Ekanyunena Purvena, for this. Okay. I just make 1 less in 42. Or to make it still simpler, make 1 less in 2, write this 4 as it is. Correct? Am I right? Yes. See, that's what I do. I just make 1 less in 2. This becomes 1. Okay. And then I write this 4 as it is. Now it has become 41. Maybe I use a different color so that it's easy for you to know. So now I got 41 here. This 41 I subtract from 99, or simple, each digit I subtract from 9. Correct? Now you see what I do. 9 minus 4 is 5 and 9 minus 1 is 8. That's all. I got the answer. Simple. Did you understand? See, I just made one less in 42, that is 41. This 41 I subtracted from 99. See, 9 minus 4 is 5 and 9 minus 1 is 8. That's all. I got the answer. Same way now, is it difficult to do this? No. I think you will only help me to do this, right? So please tell me what should I do now? And which digit should I accept now? See, first I take this 6 and I just make one less in 6. And what happens to this? This becomes 5. And what happens to remaining all the digits? Of course, they have to be same because I have subtracted only one from them. I write all the digits as it is. Okay, 7, 8, 9, 5, 3, 6, 4. Then what should I do? Yes, go on subtracting from here, from 9. That's all. See, 9 minus 4 is 5. 9 minus 6 is 3. 9 minus 3 is 6. 9 minus 5 is 4, 9 minus 9 is 0, 9 minus 8 is 1, 9 minus 7 is 2, 9 minus 5 is 4, that's all. Let me take this particular example. Let me take, okay, 42 the same way into 9, 9, 9, 9, 9. 5 times 9 I have taken. We will do this now. How to do this where the number of 9s are more? One way is simple. Make this side also equal number of 9 digits. See, I have got 1, 2, 3, 4, 5 9s. So make this also 5 digits. How to make 5 digits? Is it that go on writing 42, 42 5 times? No. What I do is I just put 3 zeros. That's all, no? It has become 5 digits. Then do the same process. See, 42, I make one less in 42. This becomes 41. Of course, I write the zeros as it is. Then go on subtracting from 9. See, 9 minus 0 is 9, 9 minus 0 is 9, 9 minus 0 is 9, 9 minus 4 is 5, 9 minus 1 is 8. That's all, you got the answer. Or another logical way to do the same example is, if I have got 42 and if I have got 9, 9, 9, 9, 9, you know what I do? I just make one less in 42 is 41. This 41 I subtract from 9. See, 9 minus 4 is 5. 9 minus 1 is 8. Okay, but I got 2 digits, but remaining 3 9s are there. Where should I put those 3 9s? Here, here or here? Immediately my conscience says, no, I can never put 9s here and I cannot put 9s here. Only place left 8 in between and I write 3 9s here. That's all. I got the answer. Okay, it's very logical, right? Simple, easy. You want to learn one more example of one more kind? Yes, we will learn systematically. This is one example I gave. Now let me take another special case. Okay. See, this is what we learn now. If the 9s are more, what to do? If the 9s are less, what to do? You have to think. Okay, I will not give you the solution. You should think and you should know how it is. Anyway, at the end of this course, I will tell you how to do that also. Okay, and try this 42 into 9 if you have to do this. How do you do this? Just think it over. Okay, think it over and later I will tell you when this particular sutra I will take it. Okay. Now let me take another multiplication with some other number. Okay, simple. I take maybe 1, 2, 3 multiplied by 11. In this case also I observe a property. Okay, I observe a property and any number multiplied by 11 again will become a special case. And to tell you a secret, any number multiplied by any number will become a special case only if you understand the property. Okay, but anyway I am not interested in this because then you have to remember so many properties. Okay, I am just giving some examples now. Now let us take this 1, 2, 3 into 11. I have to multiply this, right? So what I do is I just write this 3 as it is. Okay, then go for the next number, next digit, that is 2. Add it to previous one. That's all, simple. See, 2 plus 3 is 5. Again go to the next digit, add it to previous one. That's all. 1 plus 2 is 3. And then write this 1 as it is. That's all. You got the product. Simple. Shall I take another example? okay, and you have to do with me, okay. Is your paper and pen ready? Okay, start doing with me. Let me take this example, 2, 4, 3, 1 into 11. We'll do this now. Okay, what should I do now? First I write this 1 as it is, and then, yes, you are right, go to the next digit, that is 3, add it to previous one, that is 3 plus 1 will become 4, then go to the previous one, that is the 4 plus 3 is 7, go to the next one, that is 2, add it to previous one, 2 plus 4 is 6, and write this 2 as it is. That's all, I got the product. Simple, very simple, right? Like this, you take any number and that becomes a special case, whether it is 12, 13 or 256, whatever number it is, that becomes a special case. This is one thing we have to notice. Now and onwards, whenever we are solving any problem using Vedic mathematics, always pay attention to the property. Okay, the moment you understand the property, that becomes a special case. That's easy for you to do it. Let me take one simple example of algebra now. And before that, I want to tell you one interesting fact. How the name algebra came into existence? How do you pronounce algebra? Algebra, 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 algebra. Which is the right way? Oh, you all are pronouncing it right. which is the right way now? Algebra, algebra, algebra. What is the right way? You know, once what happened? Two English professors were fighting. Okay, one said, I have to pronounce E-I-T-H-E-R as either. Another said I have to pronounce it as either. You know, people pronounce in both the ways, either or either. Both of them, they started fighting. Both of them are English professors. He said, no, it has to be pronounced as either only. Another said, no, it has to be pronounced as either only. Both of them had a quarrel there. Then both of them decided that let us go to head of the department of English and talk to him. Both of them went to head of the department and told their story. Sir, he is pronouncing it as either and I am pronouncing it as either. Which is the right way, sir? Professor thought for a while and said, smiled and said, it can be pronounced in either way. See, he added one more confusion to that. Okay, so many of the pronunciations we will be always under confusion. So algebra, how it should be pronounced? And before pronouncing, let me tell you how the word algebra came into existence. That's very exciting to know. Once what happened, there was an Arab mathematician named Al-Khwarizmi, and Al-Khwarizmi came to India. He translated the work of whatever was happening, the step-by-step solution to mathematics, of arithmetic basically, and he took into Arabic countries. Later that spread into European countries. That is the history, we know that. And when it went to European countries, those people were not at all interested and they never thought that arithmetic can be done mentally. They were feeling that we should have a machine to do arithmetic. Except India and Arab countries, all the other part of the world, they were always relying on a machine to do computations. And we should be very thankful to that process. Because of that we have computers today. Okay, that's why they started inventing new machines. They all were using abacus at that time. Then Pascal invented Pascal's wheels, then Charles Babbage, then came to the machine, computer, what we have today. So those people, after some time, they accepted this step-by-step solution to the problem, which can be done using mental work and the simple arithmetic computations. And they thought this step-by-step approach, they wanted to give some name. You know what name they gave? Because Al-Khwarizmi took this process, they could not pronounce Al-Khwarizmi, and that has become algorithm. Even today in computers we use algorithm, right? From where the algorithm name came? Algorithm is basically Al-Khwarizmi's name, that's all. That is gone from here only. See, step-by-step approach went from India. That is called algorithm. We are using algorithm. And after some time again Al-Khwarizmi came to India and he thought that I have left out something. Okay, entire mathematics I have not translated. So he translated our Bija Ganitam also, unknown things, Bija Ganitam also. And then he took it to Arabic countries. There people asked him, see, you brought first something that we called it as mathematics, that is fine. What do you call it now? Another new branch you brought it. Al-Khwarizmi thought for a while and said, oh, this I name it as Al-Zabr. You know what do you mean by Al-Zabr? Al-Zabr means the left out part, that's all. See, previously I brought something, I left out something, left out part also I brought it. He called it as the left out part. Is it left out part for us? No, this is the motherland of algebra. Okay, Vijayaganitam. It went from here and he called it as left out part, algebra. This algebra went to European countries and they started calling it as algebra. Even we also started calling it as algebra only. See the history, how nice. That's why I tell you, learn history. Okay, that is exciting to know about mathematics facts. So the right way may be algebra. Okay, if you are not comfortable, call it in any name, no problem. Anyway, learning is important, not calling by names, right? So this is how algebra came into existence. Now let me take one simple example of algebra also. Okay, let me take, are you comfortable with linear simultaneous equation? You are, right? Let me take a simple linear simultaneous equation and let us solve it. Let me take this 2x plus 15y is equal to 8 and 4x plus 103y is equal to 16. Okay, and you know, you might have learnt in the school how to solve this in different ways using different methods. But now observe this carefully. Can you make out some property here? Observe this carefully. Can you make out some property? Yes, I'll tell you. See here what happened. If you observe the coefficient of x here, that is 2 and 4, and observe the independent terms also 8 and 16. Don't you think they are in the same ratio? See, 2 ones are 2, 2 twos are 4, and 8 ones are 8, 8 twos are 16, right? They are in the ratio of 1:2. Okay, this is the property I observed. The moment I observe the property, I apply a Vedic mathematics sutra, considering it as a special case. The sutra says, Anurupye shunyam anyat. Okay, what is that? Repeat with me. Anurupye shunyam anyat. Anurupye shunyam anyat. That means, if one is in ratio, other one is 0. Anyat shunyam. Other one is 0. Now you see what happened? The coefficient of x are in ratio with the independent term. Did you understand? As per the sutra, if one is in ratio, other one is 0. Now coefficient of x are in ratio with the independent term. What should be y? Tell me, this is in ratio, other one should be 0. X is in ratio now. What should be y now? Yes, you are right. So without doing anything, you will say y is equal to 0. Because coefficient of x is in ratio, y should be 0. See, you didn't do any work. Okay, you can just close your eyes and say y is equal to 0. It's over. So simple. Now let us come to this x. And to find the value of x is simple. That is independent term and corresponding coefficient of x. That's all. See, x is either 8/2 or 16/4. Is nothing but 4. That's all. Simple. Is it not simple? See, the moment you observe the property, this is what will happen. It becomes so simple. Algebra becomes so simple, so simple. Right? This is the beauty of Vedic mathematics. And even to go for the regular problem and solutions also, we will see after some time, even that is also as simple as this. Okay? This is very, very important to know that throughout the Vedic mathematics class, we are relaxed and we are learning it. But one warning I want to give you. Always remember, easiest things are very, very easy to forget. Do you agree with me? Yes. Okay, if you learn which is very, very easy thing, it's very easy to forget also. So you need to practice. Okay, we start learning Vedic mathematics now. Can you start practicing? Yes. Now we will take one sutra after the other and start learning Vedic mathematics. Okay.